Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss current flow mechanism in forward biased and reverse biased in PN junction and an idea of static and dynamic resistance. Let's begin. First, we discuss about current flow mechanism in forward biased PN junction. What is forward biased? PN junction is forward biased when P type is connected to positive terminal and N type is connected to negative terminal of the battery. Let me take a PN junction. P type semiconductor, N type semiconductor, then combined with each other, that junction is known as PN junction. If that P type is connected to the positive terminal and N type is connected to the negative terminal of that of battery, then that type of biasing is known as forward biased. Let me discuss how or what should be the mechanism of flow of current through that of PN junction in case of forward biased situation. Let me discuss it by using some key points. The applied electric field acts against the barrier field, hence the resultant field at the junction is weakened and the barrier thickness decreased. In case of P type semiconductor, the majority charge carriers are holes. And there are also some minority charge carriers, free electrons. And in case of N type semiconductor, the majority charge carriers are free electrons. Some of the minority charge carrier as holes. When we apply an external electric field, that external electric field from positive to negative, we have already discussed in that of P type semiconductor. Here is the ion as negative ions, in N type semiconductor the ion as positive ions. Positive are the donor ions, whereas negative are the acceptor ions. As a result, here a negative potential is developed and there a positive potential is developed. negative potential developed, here positive potential developed, and that region is known as the depletion region, and the potential we call it as the barrier potential. Okay. And the electric field of that of barrier electric field from positive to negative means N type to P type. As we say, when an external electric field we applied, that direction of external electric field from positive to negative, but here in that of barrier potential an electric field is created, the direction from N type to P type, which is just opposite. As a result, the net electric field is decreased. As we say here, the applied electric field acts against the barrier field, hence the resultant field at the junction is weakened, so the barrier thickness decreased. As a result, the barrier thickness gradually decreased. Since the barrier potential is very small, that potential, that developed potential negative and positive around 0.1 to 0.3 volt, hence a small forward voltage is enough to eliminate that barrier potential. As that potential, that is known as the barrier potential, in that of case is 0.1 to 0.3 volt. Therefore, in order to overcome that barrier potential, a small amount of forward voltage is enough. Let me discuss what be the mechanism exactly happened here. The free electrons in the N side move towards the junction under the influence of forward voltage, leaving behind the positively charged ions. Here we apply an external electric field, so a forward potential in order to provide. In case of N type semiconductor, the majority charge carriers are electrons, that be the movement of electrons, electrons repelled with each other. So, that free electrons in that of N side move towards the junction. Okay. Under the influence of forward voltage that leaves behind that of positive charge ions. Again, the free electrons from the negative terminal of the battery enter the N side to fill their places. Free electrons are from the negative terminal of the battery in order to fill their places as these free electrons towards that of junction. When the free electrons reach the junction, they become valence electrons after combining with the holes. Here there are holes in that of N side, free electrons are moved towards this. So, that hole is filled by that free electrons. Now, that holes are filled by that free electrons, therefore, they become the valence electrons. When the free electrons reach the junction, they become the valence electrons after combining with the holes, and these valence electrons move through that of holes in that of p side of the p-n junction. That p side of that of p-n junction, these valence electrons move. When the valence electrons move from right towards left in that of p side, the holes move from left towards right. In that of valence electrons in that of p side, they move from right towards left in that of p side, and the holes as present in that of p side, they move from left towards right. As a result, when the valence electrons reach the left end of that of p side, they move towards the positive terminal of that of a battery, and the forward current flows through that of p-n junction is due to that of majority charge carriers. Here the majority charge carriers are holes, in n type the majority charge carriers are the free electrons. Therefore, overally the current flows through that of p-n junction due to the majority charge carriers. Majority charge carrier in p type as holes, in n type as the free electrons. Due to free electrons and holes, the entire current flow through that of p-n junction due to these majority charge carriers. In the direction of flow of free electrons. We denote free electrons as dot sign. In this way, current flows through that of p-n junction in case of forward biasing. Next, we discuss current flow mechanism in reverse biased p-n junction. Current flow mechanism in reverse biased p-n junction. First of all, what is reverse biased? A p-n junction is said to be reverse biased when p type is connected to negative terminal and n type is connected to the positive terminal of the battery. Let me take a p-n junction. p-n junction is p type is connected to negative terminal of that of battery, whereas its n type is connected to positive terminal of that of battery, and that type of biasing is called as reverse biased. Let me discuss how current flow in case of reverse biased p-n junction. The applied electric field acts in the same direction of barrier field, hence the resultant field at the junction is strengthened and the barrier thickness is increased. In that of previous case, the applied electric field is just opposite to that of barrier field, but in case of that p-n junction, as the direction of applied electric field from positive to negative, so barrier field also from n type to p type. Therefore, these two are in the same direction. As a result, the depletion layer is formed. The thickness of depletion layer gradually increased as there will be the development of potential, biased potential. The increased barrier potential, that is the barrier potential, the increased barrier potential prevents the flow of electrons and the holes across the junction. Hence, a high resistance is established and no current flows. So, in order to explain it, the potential here developed, that potential is too high. As we say, the direction of applied electric field is same as the direction of that barrier electric field. The increased barrier potential prevents the flow of electrons and the holes across the junction, hence a high resistance is established and no current flows. However, at very high reverse voltage, a very small current around the order of some microampere flows through that of p-n junction due to minority carriers. Exactly in that of p type, the majority charge carriers are holes, but there are also present some minority charge carriers. Minority charge carriers are the free electrons. Free electrons that are the minority charge carriers, and in n type the majority charge carriers are free electrons, but also they are present some minority charge carriers as holes. Due to that of high resistance, no current flows, but at very high reverse voltage, a very small current around the order of some microampere flows through that of p-n junction due to that minority charge carriers. How that minority charge carrier helped to flow that very small amount of current? Let me discuss it. There are a few electrons in the p side and a few holes in that of n type, as we say. These are minority charge carriers. Free electrons are the minority charge carrier in p type and holes are the minority charge carrier in n type. In p type, the majority charge carriers as holes. In n type, the majority charge carriers are the free electrons. The free electrons in the p side moves towards the junction and the holes in the n side moves towards the junction under the influence of reverse voltage. Hence, a very small amount of current flows in that of reverse direction, which is known as reverse current. Okay. So, in overall we can say in forward bias situation of p-n junction, current flows throughout that of p-n junction, but in a reverse bias situation, no current flows. No current flows about that of p-n junction, but in some amount of current flow, which is known as the reverse current, due to the minority charge carriers. In this way, we explain the current flow mechanism in case of forward biased and reverse biased of p-n junction. Again, we can show the resistance term in case of p-n junction, that is known as static and dynamic resistance. What is static? Static resistance of p-n junction is defined as the ratio of voltage across the junction to the current flowing through that of junction. And the static resistance is also known as DC resistance of p-n junction. Mathematically, we can write it R of DC, that is the potential divided by current, where V, that is the voltage across the p-n junction, I, that is the current across the p-n junction. Another type of resistance which is known as dynamic resistance. So, dynamic resistance of a p-n junction is defined as the inverse of slope of the volt ampere characteristic of p-n junction. What is volt ampere characteristics? If we draw a graph in between current and voltage, V along x axis, for positive we call it as V forward voltage, for negative V reverse voltage, current for positive forward current, for negative reverse current. The graph is looking like this. The dynamic resistance is also known as SC resistance of p-n junction, and it can be written RSC is equal to dV by di, whereas dV by di that is the slope of the volt ampere characteristic of the p-n junction. If V is positive, then p-n junction is forward biased. If V is negative, then it is called p-n junction is reverse biased, and the value of reverse voltage at point P is known as breakdown voltage. Here the voltage is known as breakdown voltage. So, let we define what is breakdown voltage. Breakdown voltage, it is the maximum reverse voltage, it is the maximum reverse voltage at which the p-n junction breaks down. The p-n junction breaks down with sudden increase of reverse current, with sudden increase in reverse current. Similarly, the value of forward voltage at point A is known as knee voltage, that is known as knee voltage. Knee voltage. What is knee voltage? To define knee voltage, it is that forward voltage, it is the forward voltage at which the forward current starts to increase rapidly. So, in that of graph we show what is breakdown voltage and what is knee voltage. In this way, we discuss static and dynamic resistance, idea of breakdown voltage and knee voltage. So, here with the help of this video lecture, we understand the concept of current flow mechanism in forward biased PN junction, current flow mechanism in reversed biased PN junction, an idea of static and dynamic resistance. So, with this useful and informative notes, let me wind up this session. Thank you.